Hi, welcome to our Chapter 6 review video. All right, let's just dive on in. So, like always, don't forget to stop and read that Frappy. Tacos are awesome. Here's a 15-minute timer and instructions, and we're ready to start going through. You can always look up the PDF for this Frappy going to your assignment. Here is slide A, slide B, slide C, and slide D. Alrighty, so solutions are coming up. Don't forget to attempt these questions at least mentally before you come see me. All right. So Buckley Farms produce homemade potato chips that it sells in bags labeled 16 ounces. The total weight of each bag follows an approximately normal distribution with a mean of 16.15 ounces and a standard deviation of 0.12 ounces. If you randomly selected one bag of these chips, what is the probability that the total weight is less than 16 ounces? Cool. So I'm looking at a probability, so I'm thinking probably z-scores, normal distribution, all sorts of important stuff they told me. Not only did they tell me it was normal, they gave me the mean and the standard deviation. So I really am ready to start this question. So here is that solution. If you want, you could look at the original information. We're specifically finding a probability where the weight of the bag is less than 16 ounces. And remember, X is the weight of my bags. So I've labeled my normal distribution curve. I put my approximate 16, and I've shaded in the area I want, less than 16. So the only other information I need to get a probability from a normal distribution is the z-score itself. So I go to my z-score formula where I do observed minus expected all over the error. And so I end up with 16, the observed value that we're dealing with. They want 16 or less, or minus the expected value, the average, all over the error, or my standard deviation. So I end up looking at a z-score of negative 1.25 or less. So if I go to my z-score table, or I use an online table calculator, or I use the TI Nspire or 84, I end up with a p-value, an area under the curve, of 0.1057. There is an 11% probability of randomly selecting a bag that weighs less than 16 ounces. Ta-da! If you need a little bit more practice on that, you can go back to modeling data distributions in Khan, do their z-scores and above or below calculator probability practice. All right, if you randomly selected 10 bags of these chips, what's the probability that exactly 2 of those bags will have a total weight less than 16 ounces? Great, this means I've got binomial distribution. So I can use this awesome formula. I don't need all of this chaos, so let me break it down for you. This didn't realize I had set up the animations to go one by one. Sorry about that. This in green, you can use a calculator to find. That is the probability of your successes versus the number of successes you want. This is the breakdown of that formula using your factorials. But like I said, this is so much easier if you just use a calculator. Whether you have access to a TI Nspire or 84, or you use just any old online binomial calculator, you sure can find this information. This first probability is going to be your successes raised to the number of successes desired. This is going to be your probability of failures raised to the number of failures desired. So let's see what that looks like. In our question, our binomial right here is going to be the total number that I want, 10, and the total number of successes I want, 2. So there's total number of bags I selected, 10, and 2 of them I want to be at a weight of less than 16 ounces. This is the probability of my success. How many bags are less than 16 ounces? That would be my success right here. And then I raise it to the number 2, the number of successes I want. Where did I get 0.1057? From question A. We just solved that for ourselves. Well, where did I get 0.8943? I subtracted this from 1. You literally take the opposite. So your successes are 0.1057, so you take 1 minus 0.1057, and you get 0.8943, or the probability of your failure, the probability of getting 16 and higher, or really greater than 16, right? And I raise it to the number of failures, which would be 8. Multiply all that out, and you get 0.2057. So there's a 21% probability or chance that exactly 2 out of 10 randomly selected bags weigh less than 16 ounces. So this is a really easy question, but it's just about remembering how to set up a binomial distribution and how to recognize it. If you need more practice on discrete random variables, please go here. This one was a little tough. I understand. We struggled with this even in class. So please do go practice a little bit. Buckley Farms ships its chips in boxes that contain 6 bags. The empty box has a weight of 10 ounces and a standard deviation of 0.05 ounces. Calculate the mean and standard deviation of the total weight containing 6 bags of chips. So this is kind of an interesting. So the first thing I did is I let B be the weight of the box, that 10 ounces, and C is the total weight, so everything, the box and the 6 bags of chips. And then, of course, our bags of chips is X. We've already declared X is our discrete variable for the weight of the bag of an individual bag of chips. So we end up with the total weight of the box would be equal to the weight of the original box plus the weight of the 6 bags. Doesn't that make sense? That's nice and easy. So we plug that number in. The mean value of the box would be 10 plus 16.5 plus 16.5 plus 6, et cetera, et cetera, et cetera. That's it. That's it. So I end up with 106.9 ounces. Pretty easy. Let's move on. To get the standard deviation, well, remember, when we're combining and we're dealing with discrete variables, we can't deal with the standard deviation the way it is. So I can't just add a bunch of standard deviations. It doesn't work that way, but I can do it with the variance. So isn't that nice and easy? So remember, a variance is just the square of the standard deviation. So if I deal with the square of each of those values, I can add them. So the standard deviation of just the weight of the box was 0.05. So 0.05 squared becomes the variance of it. The standard deviation of each bag of chip was 0.12. So 0.12 squared becomes the variance. So I'll end up adding all my variances, and I end up with 0.1364. But we're not done, because that's just the variance. To get the standard deviation, we take the square root, and we end up with 0.36 ounces. That's it. Last question. Right, if you need practice, if you need practice. So if you need practice on mean values, this is for you. If you need practice on standard deviation, this is for you. Buckley Farms decides to increase the mean weight of each bag of chips that only 5% of the bags have weights that are less than 16 ounces. So we're referencing back to A, when we calculated that about 10.5, right? About 11% of the bags weighed less than 16 ounces. So we want only 5. So what do I have to do? The original mean weight, I have to increase it to reduce the number of bags that are below 16 ounces. So our standard deviation remains the same. What should I change the mean weight to? So if I remember going back to A, we worked that question forward. Basically, go back to question A and work it backward. Instead of solving to your probability, we have the probability. We know we have 5%. So I draw out my normal distribution. I shade in the 5% I care about. And now what's the next thing I need? I need that z-score right there. So I solve backwards for a z-score. So an area of 0.5 corresponds to a z-score of negative 1.645. Either I use the calculator, an online program, or I went to the table and solved backwards. It doesn't matter how you did it. We got negative 1.645. If I plug that z value into z is equal to the observed minus the expected over error, then I end up with z is equal to the observed minus the expected. We don't know the expected this time, right? We want to know the new average. So we don't know the mean, and we divide by the error. If we solve this out, we get up a mean average of 16.19. Not too much higher than the previous, but a little bit higher. So if Buckley wants to make sure that we have less than 5% below 16 ounces, then we have to use an original mean weight of about 16.2 ounces to make sure that only 5% of our bags are underweight. And that's all I got for you guys. So here is that unit practice from Khan. Of course, at this point, you can skim through, or you can do your 3 assignments, option 1, 2, or 3. Bye.